Hi guys, welcome to my YouTube channel. Thank you for subscribing and staying tuned. If you're new here, please don't go far before you hit that subscribe button, and let us make mathematics and sciences a booster subject. So our topic will be on decimals, and we are going to look at conversion of recurring decimals into a fraction. So recurring decimals into a fraction. All right, so before we do that, we are going to look at what is this we are calling recurring decimals. So from our previous knowledge, we know that every fraction can be converted into a decimal by dividing, and we are going to look at the example so that we understand. Example, maybe express a quarter into a decimal. What do we get? We divide numerator by denominator. So this one we have to put 0 there and a decimal. So how many times will 4 go to 8? That is 2 times. So you find that 2 times 4 is 8, and 10 minus 8 is 2. So we put another 0 over there. How many times will 4 go to 20? That of course will be 5. I know you know that. And the 5 times 4 is 20. And the process terminates at that point. Therefore 0.25 is a terminating. It's a terminating decimal. Let us look at another example. Another example, maybe we can have a land. Well, we convert it into a fraction. We divide the numerator with the denominator. So it can't. We put 0 there. 3 will go 3 times to 10. So that 3 times 3 is 9. With 10 minus 9 is 1. We put 0 again, 3, it's 9. 10 minus 9 is 1. We put 0 there, it's 3. 3 times 3 is 9. When you subtract, it's 1. And actually, if you look at the division process, it is endless. So it means that this process is gonna not terminate, and therefore this kind of a decimal 0.3333 and so on, and the process repeats itself, is what we call recurring. This is what we call a recurring decimal. This is what we are calling recurring decimal, and it can be expressed as 0.3, and then we put a dot on the top of the recurring number, which means that is number 3 is recurring. 3 is recurring. Okay, 3 is recurring. So in this topic, we are going now to convert this we are calling recurring decimals into a fraction. In this example, we are told express 3.3737 recurring and 0.1590 recurring as a fraction. You can start with the first decimal number. We start with the first one, 0.3737. That is 37 is recurring. Now we are supposed to find the fraction that is equivalent to this recurring number. If you remember what we were doing, when we were expressing a fraction into a decimal, for example, the one we started, we said that a quarter is equivalent to 0.25, and we also said that a third is equivalent to 0.333 recurring. All right. Now, when we are told to express this one as a fraction, we are looking for a fraction that we don't know. All right. We are looking for a fraction that we don't know. So what we are going to do in this case, in the case of 0.3737, we are going to assume that fraction that we are looking for is x. So we say let x be equivalent to 0.3737 and so on. All right. Now, if this is the case, then I want to multiply, maybe we can call this one the first equation. I want to multiply x by 10, and I'll do the same to the other side of the equation to get the second equation. So if I multiply by 10, I'll get 10x as x times 10 is 10x, 0.3737. If I multiply by 10, it means that we will have 3.737. Now, if you look at these two equations, after the decimal point, they are not equal, so we cannot eliminate. So we continue multiplying. So in the second equation, we multiply both sides of the equation by 10 to get the third equation. So if we multiply by 10, we are going to get 100x is equals, if we multiply this one by 10, then the next decimal point will move to 37.37 and so on. Remember, this part is recurring. So now we have third equation. If we compare the third equation and the first equation, you realize after the decimal point, the decimal part of that number is the same. So it means that it is easy for us to eliminate the decimal part. So what are we going to do? We are going to subtract, because now we want to eliminate the decimal part. Subtracting equation 1 from equation 3, what do we get? So we have 100x is equivalent to 37.3737 recurring, minus now the first equation, because that is what we have said, x is equivalent to 0.3737 recurring. Now when we subtract, this decimal part is eliminated. So the decimal part is eliminated, and 100x minus x, we will have 99x. So what does it mean? Remember, our interest is the value of x. So what we are going to do is divide both sides of equation by 99. When you divide by 99, they cancel, and you are left with x as 37/99. So that is the value of x, and this is the fraction that is equivalent to this recurring decimal, which is 0.3737 and so on. Right? Let us look at equation 2. So we do the same. We let that fraction that we are looking for be x, and x is equals 0.1590. Remember now, this dots means that 9090 is the one that is recurring. So we can have 90 and so on. This is now our first equation. So we do the same just like we have done in the previous decimal number. So If you multiply by 10, we are going to get 10x is equivalent to 1.59090, and this will give us the second equation. So if we compare the two, the decimal part is not equal. We have 5, 9, and we have 1, 5. So we proceed. We multiply by 10 again, we get 100x is equals, when we multiply this one by 10, we are going to get 15.9090 until to get the third equation. Now let's compare again. We have 9090 after the decimal point. We have 5909. So after the decimal point, we cannot compare. The decimal part is not the same. Then we have 9090. We have 15. So it means we proceed with the multiplication by 10 again. We have 1000x is equals 159.090 gives us equation 4. If we compare, there is nothing like this 09. This is 90. This is 590. This is 1. So we proceed again. We multiply by 10 again. So we have 10,000 x is equivalent to 1590.9090 to give us equation 5. So let's compare again. After the decimal point 9090, after the decimal point 090, no. After the decimal point 9090, look at this equation and this other equation. So compare equation 3 and 4, I mean 5. So after the decimal point, these two equations are the same. So we subtract equation 3 from equation 5. So when we have 10,000x is equals to 1590.9090 recurring, we subtract 100x, which is the same as 15.9090 recurring, and then we subtract. So this part is eliminated, and therefore if you borrow 1 here, this is 5. After we borrowed it, we were left with 8. 8 minus 1 is 7. Now we have 5, 1, right? It's equivalent to, so we have 10,000 minus 100. So we have 0, 0, borrow 1, 10, 9, 9. Remember again, we are only interested with the value of x because that is the fraction that we are looking for. So we divide both sides of the equation by 9,900 and see, let us see what we are going to get. We have x is equivalent to 1575 by 9, that one, by 5, 1, 1 because of 5 remainder 4, 9 because of 45, 9 because of 45, so there is remainder 4. This is 8 because of 40, 0. By 5, this is 3 because of 15. This is 2 by 3. Okay, this is by 5, sorry for that. 3 because of 1 because of 5, and 5 because of 25. We keep doing it. It is still divisible by 5. So we divide again by 5. This will be 3 because of 15. Remainder 4. This is 15. Remainder 4, 48. This is 9. Remainder 3. This is 6. By 5 we have we have 6. Maybe you can write it over here. We have 6 because of 30 and 3 because of 15. If you look at this one, it is divisible by 3. No, the number is divisible by 3 if the sum of its digits is divisible by 3. So by 3, 1, 3, 2. By 3, 2, 1. Maybe by 3 again, because it's divisible by 3. By 3, this is 4 because of 12, 4 again. By 3, this is 7, and we find that our x now, our x is equivalent to 7 over 44. So we have to make sure that your answer is to the simplest form. I didn't want to use calculator here because I know this topic is in Form 1 and we are not supposed to use a calculator. Therefore, I have used the knowledge of divisibility test to do my cancelling and to get the answer as 7 over 44, which is now equivalent to the decimal number, the carrying number 0.159090. So actually, the fraction you are looking for is this one, and you get yourself those free marks. I know you have enjoyed this lesson. Please make sure you share, let as many people benefit from this kind of videos as possible. Make mathematics and sciences a booster subject.